Hello, so this is Chapter 3, a brief introduction to the science of pharmacology. This is Chapter 3 of concepts of chemical dependence. Introduction. Pharmacokinetics, how time impacts a drug moving through the body. Pharmacodynamics, the way in which a drug impacts the body, including how strong or for how long. The prime effect and side effects of chemicals. Prime effects, what the drug is intended to do, the desired effects. Secondary side effects, unintended effects of the drug, often must be endured to achieve the prime effects. The method by which a compound is administered, one of three. A drug's prime and side effects are affected by the method of ingestion. Internal forms of drug administration, gastrointestinal, oral, tablet, capsule, sublingual, under the tongue, nitroglycerin, for example, and then there's rectally. The method by which a compound is administered, two of three. Parenteral forms of administration, which would be injecting drugs, skin popping injections just into the skin. Intramuscular, injected into the muscle tissue. Intravenous, injected directly into a vein. Method of which a compound is administered, 3 of 3. Other forms of ingestion, transdermal, absorbed through the skin. Intranasal, snorting. Inhalation, passing chemicals to the lung. The lungs offer a rich, blood-rich, extremely large surface area. So, bioavailability, 1 of 4. It is the concentration of the unchanged chemical at the site of action. It is influenced by the following factors. Absorption, drug molecules move from entry through various cell boundaries to the circulatory system, which is transported to the site of action. The process of drug absorption is variably depending upon the following. Method of administration, rate of blood flow at site of entry, molecular characteristics of compound. Bioavailability, 2 of 4. Distribution, how chemical molecules are spread in the body. The chemical may be water, lipid, fat, or protein soluble. A compound that is a lipid soluble will be concentrated in the brain tissue fairly rapidly, since the brain is over 50% lipid molecules, and they may form bases for synergistic effect, the combined effect of two compounds. Bioavailability, 3 of 4. Biotransformation helps the organisms cope with dangerous compounds found in spoiled foods, previously called detoxification or drug metabolism, usually carried out in the liver. Zero-order biotransformation process, first-order biotransformation process. Elimination, usually carried out by the kidneys, depends on the speed at which the process of biotransformation is carried out. Bioavailability, 4 of 4. Drug half-life, the period of time that a drug remains active in the human body. Distribution half-life, time it takes for a compound to work its way into general circulation into body tissues. Alpha and beta. Therapeutic half-life, time needed for the body to inactivate 50% of the compound. Elimination half-life, time needed to eliminate 50% of a body of compound from the body. Effective dose, ED, 1 of 2. Approximately dose at which a given percentage of the population will respond to a designated dose of a compound. Lethal dose, percentage of general population would die from a certain dose of a compound. Therapeutic window index, a ratio of the effective dose and lethal dose. Peak effects, the effects within the body develop over a period of time. Therapeutic threshold, strongest possible effects are reached. The site of action, this is where a chemical carries out its main effects, typically in the central nervous system. The receptor site, the structure of the neurotransmitter molecule fits into the receptor site and a key in a lock. Neurotransmitter may be retrieved by upstream neurons destroyed by enzyme near receptor site, or diffuse into surrounding areas. Tolerance and neuroadaptation. Tolerance, shortened duration and decreased intensity of drug effect after repeated administration. Neuroadaptation, when a compound has a shortened duration of effect because neurons have learned to compensate for the presence of that compound. Metabolic tolerance, behavioral tolerance, cross-tolerance, and reverse tolerance. Up-down regulation. Neurons adjust to allow for greater reduced sensitivity to the neurotransmitter activity. If a receptor site is constantly exposed to high levels of NT, it decreases the sensibility and/or number of receptor sites available to those molecules. Down-regulate. The opposite effect, an up-regulation of receptors number sensitivity, might result from lower levels of a given NT. Drug agonist/antagonist. Drug agonists are the drugs that activate a receptor site by being able to mimic or enhance the actions of a natural neurotransmitter. Antagonists are able to fit into a receptor site without activating it. Partial agonists are able to only weakly activate receptor sites while blocking other drug molecules from binding. Drug agonist/antagonist 2 of 2. Potency. The potency of a biological active compound is the ratio between the size of the dose and the desired response. Some compounds are much more likely to achieve an action with a smaller dose than it may take another compound a much larger dose to achieve. And then this last slide, the blood-brain barrier. The blood-brain barrier is a thin layer of endothelial cell tissue and astrocytics of the brain, which separate the brain from direct contact with the circulatory system. The BBB is a screen that keeps unwanted substances from circulating in the brain, and it's made up of a layer of cells called the astrocytics. So that's it for this. I might have to listen to this again to really get the information to stick. So listen to it as many times as needed. Thank you for listening at all.